Good evening, students. In this lecture, we are going to discuss about the numericals of quantum numbers. So here we have the first question where they have given n, l and n value and they are asking you to find out the azimuthal quantum number and magnetic quantum numbers. So how to solve this? Before you start, you have to mark the values of L 0, 1, 2, 3 and so on. So what are the orbitals of this? So we can write like this. 0 means S, this is P, D and F. So for the subshells or orbitals we can denote like this. Now how do you calculate these questions? First one, n value is given as 3. Now if there is some n value, the L values will be 0, 1, 2 and the last value is n minus 1. So we have already discussed this. Now what is the value of n here? N is equal to 3. So therefore n minus 1 is equal to 2. So hence we can write L is equal to 0, 1 and 2. So for the question number 1, we got this solution. Very simple. L value can be whole numbers, therefore 0, 1, 2 and the last number should be always n minus 1. Here what is n? 3. So what is n minus 1? 2. Hence the last azimuthal quantum number will be 2. So hence we write 0, 1 and 2. Apply for the next one. The second one, they have given L is equal to 3 and they are asking what is the value of m. What is the formula here? The second formula, m is equal to 2L plus 1. Now substitute the value of L here. So m is equal to 2 into 3 plus 1, that is equal to 7. So values of m are 7. Now what are those actually? If you draw the box diagrams, we have 1, 2, 3, 4, 5, 6 and 7. At the center you have 0, minus 1, minus 2, minus 3 and here you have plus 1, plus 2 and plus 3. So if you are taking the number of orbitals are 7 and the values of m are nothing but 0, minus 1, minus 2, minus 3, plus 1, plus 2 and plus 3. Now the third question. It says that the value of n is 2. So if principal quantum number is 2, what are the values of L and m? Now we know. So based on the first one you can write like this. L can be 0, 1 and so on up to n minus 1. So what are those now? N minus 1 is nothing but 2 minus 1 which is 1. So we can write it as 0 and 1. Very simple. Either you can go with the formula or you can use the box diagrams. If you take n is equal to 2, you are having so 1s, 2s and 2p. So based on that it is very easy for you. What is the value here? L is 0, you know that. If L is 0, it is yes. So S, it is 0. Here also what is the value of L? 0. Now for P, what is the value? L is equal to 1. Either you can draw the box diagrams or you can use the formula. Now what is M here? M is nothing but 2L plus 1. So L values are here. First one is 0. Nothing but 2 into 0 plus 1 which is 1. And for the second one, 2 into 1 plus 1, nothing but 3. So we can write like that, very simple. If at all you are having s orbitals, for that we can write the box diagram like this and the value of m is 0. If it is p, that is nothing but 2s and 2p, we will write like this. 3 box diagrams in that you are having 0, minus 1 and plus 1. Hope you are able to understand. If it is 0, that is s orbital, you will get one value of m, nothing but 0. If it is p, you will get 3 values, nothing but 0, plus 1 and minus 1. Now let us see the next question. They have given here, describe the following orbitals. Now n is equal to 1, so therefore write 1. Now L is 0. If L is 0, it is known as yes, hence the answer is 1s. Second one, n is 2 and L is 1. So let us write a 2 and then L1 means it is P. Answer is 2P. Coming to the third question, n is 3 and L is 0. So So principal quantum number 3 you write, and 0 means yes, hence orbital will be 3s. Now the last one. So principal quantum number n is 4, and then if it is 3 means the subshell will be f, hence we can write f. So finally you can write it as 4f orbital. So this is the solution for the second question. Now the last one, designate the electrons with the following set of quantum numbers. Now let us see the solution. Now the third one, we have given n is 2 and L is 0. So if n is equal to 2, principal quantum number is written as 2. Now L is 0, hence we write it as 2s orbital. Later we will discuss about this. Next, n is 3 and 1, hence we write it as 3p. Third one, 1 and 0, hence we write it as 1s. So these are the orbitals now. But what about the magnetic quantum number and spin? For that you write 2s. In the Bose diagram you will get 2 electrons. In that, now we know that m is equal to 0. What is the value of s here? S is equal to plus half. Why you wrote it as plus half? Because it is having clockwise spin and written as upward direction. Next, second one, the spin is minus half. Arrow mark down indicates the anti-clockwise spin. All this we have discussed. Now here they have mentioned it as plus half. Hence we can say that this particular electron is having clockwise spin. Clockwise spin. So this is about the first one. Now second one, you got 3p. If you draw the box diagram for 3p, you get like this, and in that the electrons are represented like this. 3 are in the clockwise spin, remaining 3 are in the anti-clockwise spin. Representing the m values, we know this is 0, it is plus 1, and this is minus 1. So they have mentioned it as plus 1, hence which one we will choose? This particular orbital, nothing but you can write it as 3px, 3py and 3pz. So very simple, they have given n is 3 and L is 1, so you got 3p. In that again 3px, 3py, 3pz, m value is plus 1, hence you get 3px and plus half. So s is equal to plus half. Therefore, it is having clockwise spin. Clockwise spin. We are talking about this particular electron. Next, third one is 1 and 0 is mentioned, and 1s. If you draw 1s, you have 2 electrons and m value is equal to 0. What about the spin? First one is clockwise spin and second one is anti-clockwise spin minus half. They are giving that you are having spin is minus half, hence we can say that this particular electron is having anti-clockwise spin. So hope you are able to understand, we are discussing about this particular electron. So in this way you can solve the questions based on quantum numbers. Now let us move to the question number 4. Now the fourth question is, they have asked you to give reason which of the following sets of quantum numbers are possible. To start with this, let us write the orbitals first. N is 1, L is 0. So I already told you, you need to represent L and the values are 0, 1, 2, 3 and so on. So what are the orbitals here? If you take the orbitals, you will get S, P, D, F. Now you can answer very easily. So what is the value of L? L is 0, hence we can write it as this is 1s. Second one, again it is 1s. Third one, 2 and 3. So n value is 2. What is L now? So 3 means F, hence we write it as 2F. Next one, 3 and 1, hence it is 3P. Next, 0 and 0, so very easy, n is 0 is never possible, so we can say that this is not possible since n can never be 0. Next, n is 2 and 0, so it is nothing but 2s. Now let us identify whether these are possible or not. Now 1s is drawn. So in this, what are the values of n? N is equal to 1 you got, L is equal to 0. Now M is 0 and S can be plus half as well as minus half. But what is given? M is minus half, but M is always 0 here. Hence we can identify that this 1s is not possible because M cannot be minus 1. Next, in the same way, here M is 0, it is possible, and S is minus half. So this second electron is having minus half, nothing but anti-clockwise spin. We have discussed all this in detail, so hence we can solve this very easily. So this is possible. All the 4 quantum numbers are possible. Coming to the third one, it is 2f. Now we know that f orbital is possible only from 4. So here you cannot get this orbital. So if you are drawing this in this, we know that 2s and 2p are possible, but not 2f. Next, in the third one, we can say 3p. Let us draw the orbitals here. Nothing but 3px, 3py, and 3pz. So you know the values. This is plus 1, 0, and minus 1. So here they have mentioned it as 1. So 1 is possible, and minus half. So you are having anti-clockwise spin. So hence this is also possible. All the 4 quantum numbers are possible. Now coming to the next one. Here itself we have understood that the principal quantum number is always 1, 2, 3, 4 and so on. Hence we can say that n is 0 is not possible. Now the last one. So we will draw the orbital diagram for this. So it is 2s with the 2 electrons in that. Now the values are m is equal to 0 and then spin values are plus half and this is minus half. So they are represented it as minus half, m is equal to 0. So we can say that these quantum numbers are possible. So after this we say B is possible, D is possible and F is possible. Hope you have understood this. Now let us move to the competitive examination questions. So in this question number 1, they have given you what are the maximum number of subshells or sublevels, orbitals and electrons in n shell. Now for this, you know, always subshell is indicated by n and orbitals are indicated by n square and number of electrons are indicated by 2n square. So we should know this formula. Depending on this, what is n here? We know that k, l, m, n are the shells and n values are 1, 2, 3 and 4. So therefore we can say that n value is 4. Now what are the subshells here? First one, n is 4. Second one, what is n square here? 4 square, nothing but 16. Third one, 2 into 4 square, that is 2 into 16, nothing but 32. So we have subshells 4, orbitals are 16 and number of electrons are 32. So we can say that option C is right, 4, 16 and 32. Hope you have understood this. If you know the formula, it is very easy for you to write. Now second one, if there are multi-electron atoms, which orbital have same energy? Hope you have written this, I can erase. How do you identify both the orbitals are having same amount of energy? For this, you should know that n plus L value should be the same. So if at all you are having value of n and L both are same, if you add this, the sum is same, then we can say that these orbitals have same amount of energy. So let us see that. First one, so option 1, we are having n is 1 and L is 0. So therefore what is n plus L value? 1 plus 0, nothing but it is 1. Second one, 2 plus 0, it is 2. Third one, 2 plus 1, the value of this is 3. Next, 3 plus 2, it is 5. Here also you are having 3 plus 2, nothing but 5. So we can understand that here 1, 2 and 3, but the last two we have same number of n plus l, hence we can say that fourth and fifth option will have same amount of energy, hence we can select the correct answer, that is 4 and 5. Hope you have understood this. Now let us see the question number 3. So let us see the question number 3 and 4. So question number 3, they have mentioned that the values of 4 quantum number of the valence electron of an atom is given as NLMS with these values. Now they are asking what is the element. So either it is potassium, titanium, sodium or scandium. So before that you should know the atomic number as well as electronic configuration. Now how to solve this? They have mentioned the valence electron. First write n is equal to 4 and l is 0, hence it is 4s. In this 4s you are having 2 electrons. So before this what you get? You get 1s2, 2s2, 2p6, 3s2, 3p6, and here you are getting 4s. Now they have mentioned it as plus half, so let us not take this. The valence electron is only plus half, hence you are having 4s1. So let us write it as 4s1. Count the number of electrons, how many you have. Up to this you have 10, and this is nothing but argon 18, and this is 4s1. So this particular configuration belongs to potassium. As you know, atomic number is 19, argon 4s1. So hence the answer is A. Hope you have understood this. What we have done, first let us take the orbital. After taking the orbital, write the configuration. Hence based on the configuration you can get the atomic number, and finally the answer also you can write. The same thing can be applied to the other atoms. Now question number 4. What they have mentioned, they are asking you what are the impossible set of 4 quantum numbers of an electron if n, l, m and s values are given. How to solve this? Here they have mentioned now 4 and 2. Again you know L and orbital values 0, 1, 2 and 3. This is nothing but SPDF. So with this information, first you write the orbitals. So 4 and 2, what you get? So here 2 is D, hence it is 4D. Next 4 and 0 gives you 4S, and 3 and 2, nothing but N is 3. So here 2 is mentioned, hence you get a D. So the orbital is 3D. First write the orbitals. Now last one, 5 and 3 will give you 5F. Hope you have understood this. Now among this, which is not possible? First one, 4D. D has 5 orbitals, and you know the values m is equal to 0, plus 1, minus 1, plus 2 and minus 2. So these are the values of m, and in that you are given with minus 2 and the spin is clockwise. So let us see where is minus 2. This is minus 2 and you are having an electron here. So S is equal to minus half. Hope you have understood this. So this is possible. Next 4s, box diagram for this is like this, and 4s if you take, 2 electrons are present in that. Now what are the values of m here? You know that m value is equal to 0 because only one orbital, it is 0, and the spin is clockwise, so this will be your clockwise. So S is equal to plus half. They are discussing about this particular electron, hence this is also possible. Coming to the third one, so it is 3D, 1, 2, 3, 4 and 5 orbitals, and in that you are having 0, minus 1, minus 2, plus 1 and plus 2. So m values are given. Now the problem is they have mentioned that m can be minus 3, but minus 3 is not possible in the case of 3D. It is only either plus 2 or minus 2. Hence this particular quantum numbers are not possible. Let us see whether the last one is possible or not. They have mentioned 5F. So F is having how many orbitals? 7 orbitals, and the values you know. This is 0, minus 1, minus 2, minus 3. Here you have plus 1, plus 2 and plus 3. So m is 0, possible. In that, the spin is given as minus half. What is minus half here? Arrow mark down. So hence we can say that anti-clockwise spin is possible. So this is also possible. Which is not possible? The third one is not possible because m cannot be minus 3. Hope you have understood this. Let us move to question number 5. Now let us see question number 5, 6, 7. So question number 5, they have given the m value not possible for double dumbbell shaped orbital. So you know what is meant by double dumbbell shape, no? We have SC spherical. So the S orbital is spherical. Next, P is dumbbell. D is double dumbbell shape. And F is irregular or complex. So here they are asking about so d orbital. Now what are the values which are not possible? If you draw the box diagram, you can write like this: 0, minus 1, minus 2, plus 1 and plus 2. So hence 0 is possible, minus 2 is also possible, but plus 3 is not possible. So here the m value which is not possible is plus 3. Hope you have understood the 5th question. Now let us move to the 6th one. The sub energy level having a minimum amount of energy. Again, when you are talking about energy, how do you calculate that? So question number 6, the value is n plus L. If you can identify n plus L value, then it is very easy. For this 3D, so 3 is n and d, you know, from there you can write it as 2, nothing but 5. N plus L value for 3D is 5. 5p. N is 5. And what is p? 1. Hence it is 6. Next comes 4s. N value is 4. And what is the value of s? So 0. 4 plus 0 we get 4. Last one 4p. N value is 4. And what is the value of L? 1. 4 plus 1 is 5. Now we can say that the least one is nothing but n plus L4. Hence minimum energy is 4s orbital. Hope you are able to understand. Very simple. The energy of an orbital can be calculated by using n plus L values. Now coming to question number 7. They are asking for azimuthal quantum number L, what is magnetic quantum number? So how do you give that? So question number 7, you know the formula. The magnetic quantum number m is nothing but 2L plus 1. Now they are asking you how do you relate L and m. Now let us identify this. So what you do, send 1 to other side. M minus 1 is equal to 2L. You want only L. Therefore by sending 2 to the other side of equation, you get m minus 1 by 2 is equal to L. Let us see which is correct here. M minus 1 by 2. So hence we can say that option B is the correct option. Hope you have understood this. Question number 5, 6 and 7. Now let us move to the question number 8. Now let us discuss the last 3 questions, 8, 9 and 10. What is given in the question number 8? They are asking the sub-energy level which accommodates maximum number of electrons with the parallel spin. We should know what is parallel spin and what is anti-parallel spin. First one is 4p. If you draw 4p orbitals, we get like this. These are all parallel spins, and if you put another electron anti-clockwise, it will be anti-parallel spin. So we can say that what are the maximum number of electrons with the parallel? So this is plus half, here also plus half and plus half. So we can say that there are 3 electrons here. Now second option we have, that is 6s. If you draw 6s, one is plus half, another one is minus half. Hence number of electrons are 0 with the parallel spin. Coming to 3d, if you draw the d orbitals which are 5 in number, 1, 2, 3, 4 and 5. So we can easily identify there are 5 electrons with the parallel spin, either plus half or minus half. Option D is 6p. So that is nothing but px, py and pz. Here we can say there are 3 parallel spin electrons, either they can be in the plus half or they can be in the minus half spin. So we can say here maximum number of electrons nothing but in 3D, which is 5 electrons are having parallel spin. Hope you are able to understand. This is the correct answer. Now question number 9, they have given the values of N, L, M and S, and which represents the unpaired electron present in all these 4. Any one you have to identify. Now first you can write the electronic configuration, either like that you can get, or you can calculate this particular 3 and 1. Now let us see the values given. N is equal to 3, L is 1, M is equal to plus 1 and S is equal to plus half. Now let us solve this. Option A is sodium. You know that sodium is 1s2, 2s2, 2p6 and 3s1. With atomic number 11, you know the configuration. Now it is 3s1. For this, N is equal to 3. Because S, you know the value, nothing but 0. And then, so it is 3 and 1. So wrong, because it should be 1, here it is 0. Now second one. So this is aluminium with atomic number 13. The same thing, up to here it is neon. After this 3s2, then comes 3p1. So hope you are able to understand the electronic configuration we have written. Now what is the valence electron? Nothing but 3p1. So let us write the N is 3. And then what is the value of L? L is equal to 1. Now it is matching here because both are fine, 3 and 1. What is the value of M here? If you draw this, you are having 1, nothing but 3px, 3py and 3pz. What are the values of magnetic quantum number here? This is 0, plus 1, minus 1. They have mentioned M is equal to plus 1 and also plus half. As you are aware that if arrow mark is represented in the upward direction, it is nothing but clockwise spin and S is equal to plus half. So we can say that the valence electron of aluminium will represent these quantum numbers. N is equal to 3, L is 1, M is plus 1 and S is plus half. Hope you are able to understand this. Similarly, they are asking opposite to this. They have given quantum numbers, asked the element. Now they have mentioned the atom, chlorine atom is there, and they are asking what are the quantum numbers for the unpaired electron in chlorine. Now let us write the electronic configuration of chlorine. You know the atomic number is 17. So you can write argon. Argon nothing but 18, either like that, or let us take neon, 1s2, 2s2, 2p6. Up to this it is neon. Then 3s2 and 3p5. So these two electrons are completely paired. So we are not considering that. Now if you take 3p5, so 1, 2, 3, 4, 5. Now here we can say that 3pz. So this is nothing but 3px, 3py, 3pz. We are talking about the unpaired electron, that is 3pz1. What are the quantum numbers for this? Now n value is 3. What about L? L, you know that it is 1. And M is equal to, this is 0, minus 1 and plus 1. So M is minus 1. And you know it is in the clockwise spin. If an electron is written in the clockwise spin, you will write S is equal to plus half. Now this is the answer. Let us see. So we have 3 in these cases. These two are wrong. So 3 and 1. Minus 1 and plus half. So answer is D. So in this way, By knowing the quantum numbers and the formulae of L, M and N, we can identify the numericals based on quantum numbers. Hope you are able to understand. Please do subscribe my channel and like. Thank you so much.